Stop what you are doing and think about this carefully, because what happened on February 21st, 2026 may force us to rewrite the history of Earth itself. Just 6 hours ago, the James Webb Space Telescope, working alongside the ALMA array in Chile, confirmed a scattering event from the interstellar object known as 3I, Atlas. At first glance, it sounded routine. Comets shed dust, ice breaks apart, space rocks fragment all the time. But this was not a routine breakup, and it was not ordinary debris. The cloud that separated from 3I, Atlas, was immediately analyzed using high-resolution spectroscopy. Scientists expected to see the usual fingerprints, carbon compounds, frozen water, maybe traces of ammonia. Instead, the instruments returned something astonishing. The oxygen isotope ratios, specifically oxygen 1,7 and oxygen 1,8, matched a signature that is almost never found in deep interstellar space. The probability of that exact ratio appearing randomly outside our solar system is less than 0.004%. And here is the part that demands your full attention. That ratio matches the unique isotopic fingerprint of Earth's mantle down to the third decimal place. Pause and let that sink in. We are talking about material chemically identical to the primordial composition of our planet from 4.6 billion years ago, floating inside an object that did not originate here. Imagine an object entering our solar system, shedding debris, and that debris matching the ground beneath your feet. NASA's Deep Space Network received the first telemetry at 14 UTC. The European Space Agency confirmed it 40 minutes later. Different instruments, different teams, same impossible result. The implications are simple to state but extremely difficult to accept. Either 3I, Atlas, is a fragment of Earth that was torn away billions of years ago and has now returned, or it is something even more profound, the parent body that seeded the material from which Earth formed. This is not just another rock. It is a mirror reflecting our own origins back at us. For decades, the standard model of planetary formation has held that Earth formed locally within the inner solar system. Dust gathered, collisions built planetesimals, and gravity did the rest. But this object challenges that narrative. As the debris cloud expands and the spectroscopic data becomes clearer, the numbers continue to support the same conclusion. This is the strongest evidence we have seen since the interstellar visitor Oumuamua passed through in 2017, except this time we are not watching something leave, we are studying what it left behind. To understand why this scattering event is so disruptive to established theory, we need to examine what 3I, Atlas, actually is. When it was first cataloged by the Pan-STARRS telescope in Hawaii, its trajectory was clearly hyperbolic. That means it is not gravitationally bound to our Sunday. It entered from deep space, likely from the direction of the constellation Lyra, traveling at roughly 26 kilometers per second. Initially, astronomers classified it as a rogue comet, a leftover fragment from another star system. That assumption ended on February 21st. At 9:15 UTC, the object exhibited non-gravitational acceleration. It increased speed without any gravitational trigger, and during that acceleration, it released an estimated 33,000 tons of material directly into the path of our instruments. This is the exact moment the story shifted from standard astronomy to something far more unsettling, because what those instruments detected next would challenge everything we thought we understood. What those instruments detected next did not resemble the signature of an icy wanderer from another star. The James Webb Space Telescope immediately focused its near-infrared spectrograph on the expanding debris cloud, expecting to confirm water vapor and simple hydrocarbons. Instead, the spectrum revealed heavy silicates, specifically enstatite chondrites. That detail matters more than it may seem. Enstatite chondrites are not random space rocks. They are the precise type of material believed to have built the inner planets of our solar system, including Earth, Mars, and Venus. They are rare in the outer solar system and almost unheard of in interstellar space. One unusual reading could be dismissed, but this was not a single instrument glitch. At the same time, the ALMA Observatory in Chile redirected its 66 antennas toward 3I, Atlas, measuring the thermal emission of the dust grains. ALMA confirmed crystalline olivine, a mineral that forms a major portion of Earth's mantle. Then the European Space Agency's Gaia spacecraft provided a third layer of verification. Gaia recorded a sudden brightness flare consistent with freshly exposed rocky material, not the sublimation of ice. 3 independent systems, 3 separate methods, 1 identical conclusion. The oxygen isotope ratios match the Earth-Moon system within 0.003%. In planetary science, oxygen isotopes function like a fingerprint. Mars has its own distinct ratio. Asteroids from the outer belt show another pattern. Comets from the Kuiper belt carry a radically different signature. For an object that traveled light years to display Earth's exact isotopic identity is statistically extraordinary. The odds have been calculated at roughly 1 in 4.7 billion. Under current formation models, this should not happen. If 3I, Atlas, formed around another star, it should look chemically alien. Instead, it appears like a long-lost twin, and as scientists examined the expanding debris cloud, they noticed something else. The material did not resemble weathered rock altered by cosmic radiation over billions of years. It looked pristine. It resembled raw, protoplanetary dust, the same kind of material that condensed from the solar nebula 4.567 billion years ago before Earth even developed a crust. That realization forces an uncomfortable question. If this debris is chemically identical to Earth, yet arrived from interstellar space, could it be that the building blocks of our planet did not originate solely here? Perhaps objects like 3I, Atlas, carried this material across stellar neighborhoods long before Earth formed. Or perhaps the reality is even more disruptive. The deuterium to hydrogen ratio in the released gas matches Earth's oceans precisely. Typically, comets possess elevated deuterium levels. Earth's water has a lower ratio, which led scientists to believe that asteroid impacts delivered most of it. Yet here we have an interstellar traveler carrying water with Earth's exact isotopic balance. Then the story grew even more complex. Along with dust and minerals, the scattering event released gas. Within that gas, spectroscopic lines revealed complex carbon chains. These were not simple organic molecules. They were precursors to amino acids, detected at concentrations thousands of times higher than those measured in any comet studied within our own system. When you combine mantle-like minerals with an abundance of advanced organics, the narrative shifts. We are no longer discussing random debris. We may be observing the mechanism through which life itself is transported. Trajectory analysis added another layer. When astronomers traced the object's path backward, they did not see a chaotic wanderer. They saw a route aligned with the local standard of rest, the average motion of stars in our region. It was as if this object had been moving slowly relative to us, waiting for our solar system to intersect its path. And then, on February 22nd at 4:15 UTC, the Deep Space Network station in Canberra recorded something that defied classical expectations. According to Newtonian gravity, an object moving away from the Sun should decelerate. Instead, 3I, Atlas, accelerated. The increase was measurable, 0.8 kilometers per second after perihelion. No visible jets, no exhaust plume, no detectable outgassing sufficient to explain the thrust. Yet it continued to speed up. Acceleration without a visible cause is not a trivial anomaly. To increase the velocity of an object estimated to be 400 meters long requires substantial energy. The conventional explanation for non-gravitational acceleration in comets is outgassing. Ice heats, vapor jets form, and the reaction force nudges the body forward. But the James Webb Space Telescope searched carefully for water vapor, carbon monoxide, and other volatiles that would indicate strong jet activity. The spectral data came back clean. There were no massive plumes, no dense coma, no detectable exhaust capable of pushing an object of this scale. In physics, if an object accelerates, a force must be acting on it. The conservation of momentum does not permit exceptions, yet here we have acceleration without observable thrust. The probability of a natural body achieving this speed increase without visible emissions is extremely small. The numbers simply do not fit the established models. It becomes even more intriguing when we examine the trajectory. When astronomers projected 3I, Atlas's path backward through the galaxy, they did not find a random origin. The path intersected closely with the local standard of rest. In simpler terms, relative to nearby stars, the object was nearly stationary. It was not racing toward us from a specific stellar system. It appears to have been drifting at the average galactic velocity, almost as if our solar system moved into its path. Because its material matches Earth so closely, this alignment raises a difficult question. How does something with Earth's isotopic fingerprint end up waiting in interstellar space? There are two main possibilities, and both challenge conventional thinking. The first scenario suggests that billions of years ago, during the early chaotic period of solar system formation, gravitational interactions with a passing star may have ejected large fragments of Earth's mantle into deep space. If so, 3I, Atlas could be a returning fragment, a relic expelled during our planet's violent youth. The second possibility involves panspermia, the hypothesis that life's building blocks travel between star systems aboard rocks and comets. If 3I, Atlas carries Earth-like material because Earth itself formed from a shared interstellar debris field, then our planet may be one member of a much larger family of chemically similar worlds. Yet the physics of its motion continues to raise concern. Observations from Lowell Observatory reveal that the object is rotating with a stable period of exactly 8.14 hours. After a scattering event that released tens of thousands of tons of debris, a natural body would be expected to tumble chaotically. Instead, 3I, Atlas stabilized within 6 hours. In rotational dynamics, such rapid damping of oscillation typically requires immense timescales or internal mechanisms that redistribute mass efficiently. Nature rarely produces such precise stabilization so quickly. Further, anomalies appeared in data from the Hubble Space Telescope, which is tracking the debris cloud. Instead of expanding symmetrically and trailing behind the object, as solar radiation pressure would predict, the debris is forming a focused stream leading the object. In other words, the dust appears projected forward. Solar wind models indicate that radiation pressure should push material backward. The observed motion suggests an additional force at work. Then the European Space Agency's Gaia mission refined the astrometric data, revealing a subtle trajectory adjustment of 0.004 degrees. At interplanetary distances, that shift is significant. It is not the behavior of a passive drifting rock. It resembles navigation, and the projected path indicates a resonance point aligned with Earth's orbital plane. All of these findings were documented within 48 hours. The isotopic match, the unexplained acceleration, the stabilized rotation, the unusual debris dynamics. Yet, even with this accumulation of evidence, the most startling discovery was still to come. On February 22nd at 8:30 UTC, the ALMA observatory detected molecular signatures that no one anticipated. The array was scanning for simple carbon monoxide lines when it instead identified a dense cluster of complex organic molecules. Among them were glycine, phosphorus-bearing compounds, and molecular precursors associated with RNA formation. We have found amino acids in meteorites before. However, such discoveries typically reveal a balanced mixture of left-handed and right-handed molecular structures. In chemistry, life on Earth uses almost exclusively left-handed amino acids. Abiotic processes generally produce a 50-50 mix. ALMA's data revealed an enantiomeric excess. The amino acids in the debris cloud were predominantly left-handed. That detail cannot be ignored. Chirality, or molecular handedness, is a defining feature of terrestrial biology. The probability of a purely natural process producing a strong left-handed dominance in interstellar space is extremely low. If the data holds, it suggests that the material within 3I Atlas may once have been part of a biological environment. The implications are profound. If this object is a fragment of ancient Earth, it may contain preserved chemical remnants from our planet's earliest biosphere. If it originated elsewhere, it suggests that life with the same biochemical orientation exists beyond our solar system. Shortly after this discovery, the SETI Institute directed the Allen Telescope Array toward 3I Atlas. They were not searching for conventional radio broadcasts. Instead, they monitored for optical or infrared pulse patterns. For 12 milliseconds, the array recorded 3 infrared spikes separated by a precise interval of 1.618 seconds. The sequence repeated 3 times. The number 1.618 corresponds to the golden ratio, a mathematical constant observed in geometry and growth patterns. Natural astrophysical processes do not typically generate repeating pulse intervals aligned with this constant to multiple decimal places. Pulsars emit regular signals, but not in golden ratio sequences. Random gas emissions do not produce structured repetition. While officials have not issued formal conclusions, the data itself is documented. The object is accelerating without visible propulsion. It carries Earth-matching isotopic material. It contains predominantly left-handed amino acids. It emitted a repeating infrared pulse aligned with a fundamental mathematical ratio. We must be cautious, yet we must also be honest about the observations. These are not speculative rumors. They are confirmed detections from NASA, the European Space Agency, and independent research institutions. Now we face a question that remains carefully unspoken in public briefings. If 3I Atlas is composed of Earth-like material and carries the molecular signature of life, what is its purpose? Is it simply returning, a natural relic crossing our path by coincidence? Or is it interacting with our solar system in a more deliberate way? Because the answer determines how we interpret everything else. If this object is a natural fragment of ancient Earth, then panspermia becomes far more than a theoretical curiosity. It would mean that life's ingredients can survive ejection from a planet, travel across interstellar distances, and remain chemically intact for billions of years. Under that scenario, life is not rare or miraculous. It spreads through impact events, riding rocks across stellar neighborhoods. But if the acceleration pattern, the rotational stability, and the infrared pulse sequence are intentional rather than incidental, the implications deepen. An artificial probe designed to transport biological material would explain the stabilization mechanism. It could account for acceleration without visible exhaust if propulsion methods beyond conventional chemical rockets are involved. Even the golden ratio pulse might represent a mathematical signal, a universal language independent of culture. We must emphasize that extraordinary claims require extraordinary evidence, yet the data demands rigorous examination. The Green Bank telescope is now locked onto the signal source, 3I. Atlas is crossing the orbit of Mars. Within 14 hours of the initial acceleration measurement, it will reach its closest approach relative to the Earth-Sun line. At that moment, any change in trajectory or signal pattern will be critical. If the object alters course again beyond gravitational expectations, the argument for natural coincidence weakens further. If the pulse sequence changes, repeats, or intensifies, the interpretation may shift dramatically. Scientists are careful with their language. Public statements refer to anomalous acceleration and unexpected molecular composition. Behind those phrases lies a deeper tension, the possibility that our solar system has encountered not merely debris, but an artifact or vector carrying the blueprint of life. We stand at a crossroads between two transformative explanations. In one, 3I, Atlas is a relic of violent early solar history, a shard thrown outward and now returning after 4 billion years. In the other, it is part of a broader cosmic process distributing compatible chemistry across habitable worlds. Either conclusion reshapes our understanding of Earth's origins, and the clock is still moving. As you watch this unfold, telescopes around the world remain fixed on 3I, Atlas. Data streams continue to update in real time. Every measurement refines the picture, yet the core anomalies persist. The isotopic match to Earth's mantle remains within thousandths of a percent. The deuterium ratio aligns with Earth's oceans. The acceleration continues without detectable outgassing sufficient to explain it. The rotation period remains stable at 8.14 hours. The debris stream still behaves in ways that challenge solar radiation models. This convergence of independent observations creates a scenario where coincidence becomes increasingly difficult to maintain. Each anomaly alone might be dismissed. Together, they form a coherent pattern demanding explanation. If 3I, Atlas, is natural, then our models of planetary formation must expand to include large-scale exchange of material between star systems. It would imply that chemically similar planets may be common in this region of the galaxy. Life's building blocks would not be unique to Earth, but distributed widely. If it is artificial, then we confront a different reality. The acceleration suggests control. The pulse sequence suggests intention. The biological chemistry suggests compatibility. In that case, the object is not simply passing through, it is interacting. Within hours, it will reach its critical alignment point relative to Earth's orbit. Observatories are prepared for any deviation in course or signal. The coming data will either reinforce a natural explanation or push us towards something unprecedented. We are no longer debating distant speculation. We are analyzing real-time measurements from multiple independent institutions. The significance lies not in dramatic headlines but in reproducible data. History has moments when assumptions fracture. When telescopes first revealed that Earth was not the center of the universe, the paradigm shifted. When exoplanets were confirmed, our sense of isolation diminished. Now, we may be witnessing another transition. Whether 3I, Atlas, proves to be a returning fragment, a cosmic courier of life, or an artifact with intention, its arrival has already expanded the boundaries of inquiry. It forces us to reconsider where Earth's material came from, how life's chemistry originated, and whether the processes shaping habitable worlds operate on a galactic scale. The debris continues to disperse, the signal pattern remains under scrutiny, and the object moves steadily along its adjusted path. We are observing an event billions of years in the making. The data will decide which explanation survives. Until then, we remain in that rare position where science stands on the edge of a profound answer. If you want to follow every update as this story develops, stay with this channel, subscribe now, and turn on notifications so you don't miss the moment when the next transmission arrives.